Hi everyone, in this video I'm going to explain how to find the derivative using the change rule. The given equation is explain why the derivative of a composite function y equal to sin 3x squared plus 1 5 require repeat application of the chain rule. Show the solution. Okay, step 1, we identify the layer. We have 3 layers. We have outer layer, middle layer and inner layer. Okay, because this function has layer, we use the change rule. The change rule formula is dy per ds, dy per du, du per dv and dv per ds. This means we differentiate from the outside to the inside. For the step 3, differentiate the outer layer. We start with the outer layer. So the outer layer we get cos 3s square plus 1 5. So for the sin we transfer to the cos. Step 4, differentiate the middle layer. Next we differentiate the middle layer. For the middle layer, 3s square plus 1 5 using the power rule, d per ds, u 5 for example. So it's equal to 5 4. Here's the 5 1 we got to here, and the 4 need from 5 minus 1, so we got 4. So the result is 3s square plus 1 4. The 5 1 we go to here, so it's going to be 5 here, and here we minus 1, so we got 4, so it's will be here. That's for the step 4. Now we're going to step 5. Now we differentiate the inner layer. For the inner layer, we have 3s square plus 1. Derivative of 3s is 6s and the derivative of 1 is 0. Let me show you. So the 2 is going to here, so it will be 6s, and the 1 is actually have a 0 equal. So when we go in here, so it will be 0 times 1, so it will be also will be 0. So we don't need to show it. So the equation is 6s. Okay, that's for step 5. Now we're going to step 6. Finally we multiply everything together, combine all the result. Dy per ds equal to cos 3s square plus 1 5. Yeah, cos 3s 5 3s square plus 1 4 and 6s. The dy per ds to 3s equal 3s square plus 1 4, and next cos 3 s square plus 1 5. Okay, 6s we're going to here 5, 6 will be 30 and cos will be back here, so it will be like this, the same question. So for conclusion, to conclude, we use the chain rule because the function has multiple layers. We differentiate each layer step by step and then multiply the result together. This is the final answer. Thank you for watching.
Nice, Adik. Now I know to solve the question. Now give me a chance to solve my question. My question is to find dy over dx for function exponent for x sin 2x over x square plus 3. The function is exponent for x sin 2x over x 2 plus 3. First step, identify part of the function. So this is numerator for u and denominator for v. After that, we differentiate using the quotient rule. So formula for quotient rule is v u prime minus u v prime over v square. For second step, differentiate each part. So u is exponent for x sin 2x and v is x square plus 3. V prime is 2x. So what is u prime? So for u prime, we use a product rule. So formula for product rule is v u prime plus u v prime. So u is exponent for x and v is sine 2x. U prime is 4 exponent for x and v prime is cos 2x multiply 2. Why we multiply 2? Because differentiate 2x and we got 2 cos 2x. Now I substitute the value to the formula. So v is sine 2x multiply u prime is 4 exponent for x plus exponent for x multiply 2 cos 2x. Then we can factorize. So we got e exponent for x for sine 2x plus 2 cos 2x, and this is u prime for the in the quotient rule. Step 3 is substitute the value into a quotient rule. So we know the formula is v u prime minus u v prime over v2. So just substitute the value. So dy over dx equal x square plus 3 multiply is exponent for x 4 sine 2x plus 2 cos 2x minus exponent for x multiply 2 cos 2x over x square plus 3 square. So we step 4 we can factorize the function. So we got dy over dx equal exponent for x square plus 3 4 sine 2x plus 2 cos 2x minus exponent we factorize that, I forgot, minus 2 cos 2x over x square plus 3 square, and this is a final answer I got. So that's all from me. Thank you.
Okay, given x square exponent y plus tan y cube equals to 5x minus y ln x. Find dy over dx by using implicit differentiation. Firstly, we write equation first. Want to find dy over dx. Step 1 is differentiate both sides with respect to x. Okay, first we will do left hand side first, which is x square exponent y. We differentiate sy exponent y by using the product rule. And then we differentiate another using the chain rule. Equals to, and then we move to right hand side, which is we differentiate 5x, and we differentiate y ln x, also using product rule. So we can simplify. After that, we will collect terms involving dy over dx. And then we can factorize dy over dx. And then the question want only dy over dx, so we will move it. That is the final answer.
Wow, I now understand Shahir how to solve a question using implicit differentiation. So let me explain you guys how to solve this question. For this question, you need to use linear approximation as a given formula. Okay, so for the formula is like this, guys. Okay, the first step is we need to define the function for this value. For this value, guys. Okay, yes, this value. So first we need to define a function of x. Okay, the function of x like this, guys. Okay, and then we got this. After that we define the derivative of function x. So we got this one, guys. And then lastly we need to also define a delta x, and then we know that it's like this. X is a given value and x node is a chosen value, guys. Then x is we got 11.96 and x node is 12. So we just calculate like this using formula, and then we got this for delta x. To avoid a careless, we list all of the function also delta x that we find, and then just substitute, guys, in the formula like this, and then the final answer we got 12.648. Okay, easy, right, guys? That's all.